Okay, that's better. Right. So, so yesterday we talked about how to get prompts from ChatGPT using a JSON post request. And today we are going to be talking about how we can do a little bit of additional training so that ChatGPT can get a more precise response for the things we wanted to respond to. So again, the components are the same as the post request yesterday. You have this URL that you send. It's got a header with your key, and you've got a JSON object that you will be sending to the ChatGPT API. And this one is slightly different from the previous object. Here, yesterday you would have seen that in this messages list that you're sending to ChatGPT, yesterday you would have seen just role system and its content, and you would have seen role user and its content. And today what we're seeing is some few additional things to help ChatGPT to get a more calibrated response to what we are looking for. So one of the things that you'll see here is in the prompt itself, we can see that Anand has put that he wants to not just identify good reviews, but he also wants to identify some other metrics like acting, the storyline, and direction. This /n just means new line, okay? So he's just put them on new lines. And then in the content, what he has done is he has actually put an example of the review that was there in the CSV file that you downloaded earlier. It's the same CSV file, and he has put one of those reviews. Okay, so the next thing he has done is he is now labeling, or rather training ChatGPT how to interpret this particular review. Okay, so you remember yesterday there was system, and there was a prompt for the system what to do, and then there was some content which was this bit. This bit was there yesterday. But today what he's doing is he's putting a single review, and then he's putting this new role for the ChatGPT. And the role of this part of the JSON body is to label this content that has been put here. So it's like saying, okay, I want you to read this, and this is how I rate this. So I say acting for this review is maybe good. Storyline for this review, in my opinion, is good. And the direction is good. So we are training ChatGPT on this review and saying, this is how we feel about it. And now we will send in another review, and this time it will use this sort of benchmark or this training that you've given it to conduct the rest of the reviews. So that's what this is called aspect-based sentiment. So you are training it in how you want it to interpret the prompt that you're giving. So that's what this is. And there are different terminology that's used for it. So if we look on here, he talks about zero shot, one shot, and multi-shot. So when you don't give it this second bit, this training bit, it's called zero shot. And we can even ask ChatGPT. This is one thing that we have been informed as well, is to, rather than just teach from our own knowledge, to also show you how to get your questions answered using ChatGPT. So I'm not sure if you guys have this available to yourself, but we have a specialized version of ChatGPT that has been trained on tedious subjects or tedious things, and they have put some how do you say it, some training data that it's been given and some guidelines on how to respond to it. So I'll be using this as an example today. So we can ask it this question, which is, you know, what is zero shot, one shot, and multi shot learning, and see how it responds to this. And say hi, or rather, what is zero shot? And can you explain it in simple language? And so zero shot learning is where, as it says over here, it recognizes with new and unseen categories without being trained explicitly. And that's what I was saying, that what you were doing earlier, giving it a review and asking it a sentiment, that's zero shot learning, where it just, through whatever training it's had in the past, it just hasn't, because no one has trained it specifically to say, okay, these are movie reviews, this is how you score sentiment. Somehow it guesses what the best answer would be based on all its past. One shot learning is what I showed you just now, which is where you give it one example, and that's what we did in this segment here. We gave it one example of a review, and then we labeled it. We said, okay, acting is good. We gave it some labels. So we did one training for it, and then it is been asked to, for any future prompts, you treat it the same way. Use that as your baseline. And multi-shot is just doing it with more examples and giving it better training. So that's a multi-shot. But it won't, multi-shot won't be like how LLMs are trained. Okay, LLMs are normally trained on very, very gigantic data sets crunching in big data centers. But multi-shot learning will be like a few examples we'll give it, and then it will do its best to label it based on that going forward. So those are the three things about it. I've all of you understood the breakdown of this notebook. I know we didn't specifically type through it today, but that's because part of it is you have already done this bit yesterday. The only additional bits are this assistant and this user part. Even in fact, this user part is not new. It's just that this part is new, and this is the training part of it. Is it clear to all of you? I would need some audible response, okay, because I don't have a second screen available.
Yeah.
Okay. Anyone have any questions to ask?
Sir, hello,
Yes, go
sir.
ahead. Yeah,
Myself
yeah,
Suresh.
yeah.
Uh,
Go ahead, Suresh.
sir, I'm just new to the programming. I didn't know
Okay,
what is JSON or SQL. I'm a mechan I'm a mechanical engineering graduate.
okay, okay. Have
Uh,
you watched our previous sessions on any of the scraping topics or anything of that sort? Have you seen our
no,
previous?
no, sir. This is my first TS session on TDS.
Okay. What I would suggest, Suresh, is
Mm,
you better watch some of those previous sessions, because we cover, for example, JSON,
mm.
XML, and all these sorts of things are covered in the previous sessions.
In
So
TS session, sir. In TS session.
yeah, in the TA sessions, we have covered them in the TA sessions. But I can give you a very brief overview of some topics that we are doing today.
Sir, we
So
needed some help. I needed some help. I have a project, sir.
yeah,
I don't
no,
know where to start. How to.
okay. So with regards to project, again, the best thing to do is watch some of the previous TA sessions, because there we have extensively dealt with
Mm.
what you call it, the HTML scraping. Uh, we have dealt with how to do data cleaning,
Oh,
how to process data. I would start with week 2. In fact, I can probably show you on here. So like week 2, if you
oh,
go to data sourcing, and then at the very bottom of it, you will see some resources over here. It says optional real life scraping.
oh,
This is not optional, actually. It's a very
oh,
bad word they've used here. This is actually essential. In fact, most of your grades will come out of these videos that are shown here.
Oh,
And apart from that, even now there is a link when someone has posted a link in the chat box.
some, I think
This is our,
Madhush Kumar.
yeah. So this is our current TA session playlist, and it
Oh,
will be very useful for you to go through those.
oh, okay.
So,
Thank you, sir.
okay. So I would advise you to do that.
Okay, sir. Thank you, sir.
Okay. Uh, right. So if you guys are coming from outside the organization, like you can see here, I can't allow anyone to join from outside IITM. Okay. So if you're trying to join, or if your friends try to join, I can't allow any IDs that are outside IITM. Okay, for any of these sessions. Okay. So back to where we are. Okay. So any questions related to LLMs or the things we looked at today?
Yeah, I have a question.
Okay, go
Normally
ahead.
in web we see the chatbots. So they are based on this or how is that?
Chat bots are not. This is to do. Okay, so chat bots are web scrapers. This is not a web scraper. This we have been. This is an endpoint that we have been given, and some organizations have these endpoints that are called APIs, and APIs allow us to interact with their software to get some specific results out of them. So they will, so say for example, in week 2, I think it was, you had Pokemon API, right? So when you run a program against that API, you're effectively trying to get some information from that API using some program that you've written. But when you use a program to scrape through a web page, then you're creating what is a bot. It's not a chat bot, but it's a bot. Um, when you want to create a chat bot, now this is something that will leverage AI, right? So in that sense, what you would do is you would send any questions that have been asked to this chatbot. So in some sense, this is a chatbot of some sort, right? But it's using an LLM in the background. And the if you design a chatbot, perhaps you will make an interface to your chatbot, which then sends in the background uh, a call to these APIs. And OpenAPI is not the only one. Okay, so many chatbots might use a cheaper model. So like there's Llama model, and there are like I think 50 or 100 models, LLM models. This is by no means the only one, but this is the most famous one and the most popular one. Because for many reasons, because it's very powerful, it's very effective. So in that sense, you could use this to create a chatbot. You send in prompts to it, and use the only difference being is you use an assistant to, because you don't want your chatbot to talk about everything and anything in the world, right? That would be very costly to you as a company. If suddenly someone started, so say for example, you're booking an Airbnb, and you decide you want to make an Airbnb chatbot. Great idea, but you want your customers to only use your chatbot to talk about things very specific regarding the accommodation, right? You don't want them to ask, by the way, can you teach me maths or something, right? That will be very expensive for you, because they will be using your tokens to answer questions that are not related with accommodation. So this is where, in that sense, this is where if you are creating a chatbot, you would be training it to say, okay, I want you to only respond to these types of queries, and here's an example, and then you would give some examples, and you could potentially use this to train your chatbot, if that's what you were. I mean, is that help you in any way to understand? Did I understand your question correctly?
Yes, yes. Means one thing yeah, I understood, but
Yeah.
data also means we should store within our company locally, for training.
Yes, so this is of course being sent to OpenAI. Whereas if you want to run models locally on your system, there are many such models available. In fact, I had recently tried one. I mean, I don't have it on this particular system. I have it on another machine of mine, where maybe that's something I can demonstrate for next time, where you can download an already trained model onto your system. But the only problem with that is you'll need a reasonably robust machine depending on the model. So some models are very compressed and generally can run on smaller on less resources. But then some of the more better models might take more resources. But this is rapidly changing field. Okay, some of the models, they are compressing them to the point where they can even run on a phone, and they're using the phone's AI chips to be able to process some simple amounts of prompts that have been given to it. I think there's a site called Hugging Face, I think it's called.
Yes,
Uh,
Hugging Face.
yes, correct. Yeah. And then there's some documentation available on that. I think there is a piece of software that you use called LLM Studio, I think it is called. You download LLM Studio, and then from Hugging Face, you download the model, and then you run the model locally on your system, and then you can experiment with it and refine it, do use these concepts what we just talked about, which is single shotting, multi-shotting, to train it on what you want it specifically to address. So that's possible, yeah. But we will not be, that won't be in syllabus. That's just to answer your query about it. Any other questions?
I have one.
Okay.
In zero shot, it was using a default model which was already
Correct.
present.
Correct.
So when we give training data, it updates or it makes a new one.
No, it, I mean, okay, I'm not entirely sure. What I know is it redefines its, how do I say it? It redefines how you want it to be. It doesn't affect everybody else.
Okay,
So, in
for
other
just
words,
I think.
yeah, it's only for your personal session that it does that.
Okay, thank you.
Yeah. Any other questions so far on what's been covered? Even yesterday's things, if you wanted to ask any questions about yesterday's, you can ask me.
Sir, I have recently joined. Have you thought about RAG or something like
Sorry about.
RAG, Retrieval Augmented Generation?
No, we have not dealt with that topic. I'm not familiar with what that is. Is that in week
Okay.
5?
No, sir, it's not
Okay.
related to IIT syllabus. I was just.
Okay. This is a great example, right? So one thing is we have now been encouraged to use ChatGPT, right? So what did you call it? RAG, is it? RAG.
Yes.
So what was the full form of it?
Retrieval Augmented Generation. It's like a
Retrieval.
custom chatbot.
Yeah. So you just use ChatGPT to find out more about it, and it will give you some sort of explanation about it. It's the first time I'm hearing about it. So,
Okay.
and here's the other thing about ChatGPT: you don't even have to use it just for natural language processing. You can actually use it to generate code. So that's something that we can also do in ChatGPT. Like a lot of these things that you see over here that is on this notebook, a lot of it was AI generated. If you watch the video, you will see that whenever they ran into a problem, they just get a suggestion from ChatGPT itself, and it generates the code for you. This is something I'm not very experienced with because I've not used it that much, but I know a lot of students do use it as well. And that's something we can, you and I, both of us can practice going forward as well. If there are no other issues about what we've discussed so far, we'll go to the next bit, which is LLM extraction. So LLM extraction is about, you have some unstructured data. So in this case, You have this address. You don't know. I mean, the reason. Okay, so this is sort of semi-structured. Okay, in the sense that you know, okay, it's an address and there's a place, but this is unclear what it is. I mean, is this a house number? Is this a street or a city name? I mean, of course, we know from experience what these are, but in some sense, this is unstructured data because it is just a piece of text. And the idea behind LLM extraction is to get structured data out of unstructured data, okay, or semi-structured data. And why is that useful? Because once we get structured data, we can do lots of powerful things with it, right? When we think about your project, for example, if you can somehow extract all the information you want and put it in a nice structured CSV, that's great, right? If you are able to do that. Because if we just look at your project, for example, so it looks nice and structured, but let's see if we if I copy paste this or something and try sticking it in Excel. Let's see what happens. Okay, it's taking a little bit of time.
It comes in a single column.
So yeah, I mean, this is terrible, right? This is no good. So although it looks structured, I mean, this has been deliberately done, okay? So so that so in reality, although this looks like structured data, in the background we have deliberately made it such that it doesn't come out in a structured way. So this is now not really structured data. In the same column, there's all sorts of stuff in there. So this is not very useful to us. So the question is then, how do we extract something that is unstructured and make it into something structured, make it into a nice CSV table so that you can solve your project? I mean, that would be great, right? So that's what LLM extraction is about. It's leveraging the power of large language models to understand context and then produce a very structured output out of it, which we can use. And in fact, you guys can try this when you have a chance with your project, okay? To see if you can find a way to do it using an LLM. That would be fantastic. So if we go down here, all they are doing is, once again, they're hitting they have created a new function here. Last time it was the function was to do with the movies. This time it's about extracting the address from the unstructured data. Again, notice it's the same thing. You got a URL, you got a header with the key, and then it's sending some data to it, which is having the model. And here is another interesting thing. We are saying to ChatGPT, we want this response not in the nice usual natural language that we are used to, but actually we want it in a very specific format. So this keyword response format tells it we want it back in a JSON object, whatever the response is. Then we send it the prompt. So the system role we give it, and notice he hasn't explicitly mentioned anything in here. No, sorry, he has actually. This is a what you call a multi-line string. So in here he has put extract the state name, zip code, country, and he's also mentioned use this sort of formatting. So although this says get the response as JSON object, it doesn't know how many fields you want, for example, what you're kind of looking for, right? I mean, because this could have been, we could have said, okay, I want it in this format where numbers are written in a field called number, and then I want some other fields where capital letters are written in a field called capital. So it doesn't know, right, what you're looking for. So, but by explicitly saying that, okay, whatever information we give you, this is the context for it. I want a JSON body, but I want it in with a key name, state name, zip code, country, and basically try your best to fit it into this. So that's what we are telling it over here. So that's the prompt. Then as usual, the role user, and we give it, just remember, this is exactly the same as what we saw over here with the review. It's just a different prompt and a different content is going into it. And there is one extra thing. We are explicitly telling how to get the response out. And then when we see the result, this is how it puts out the result. It puts it in a JSON with the key name, state name, and it tries its best guess at what this is. It doesn't know that Washington DC is not a state, but it's a best guess. And then it puts a zip code, and I think it manufactured the country, I think, did it? Yeah, so it guessed the country also, because in our prompt, we said we wanted a country, right? But there was no country in there, so it guessed what the country was. So that's what's happened here. But the key thing is, unlike the sentiment analysis, this has come out in a nice format that is that allows us to do processing on it. So that's how you do LLM extraction. Now the next bit is a little more complicated, but so far, have you all understood what how this works, right? Can you?
Yeah.
Do you have any questions? Do you have any questions at this point? No questions? Okay. So this next part is a little bit complicated. Okay, it took me a while to also understand this. So now, although this seems to work fine, sometimes what happens is this is still how should I say it? This is still flexible. It may not always give you exactly this result or this kind of structure that you're looking for. So in order to fix it like a blueprint almost, like I want you to do exactly something like this, right? If you wanted to give a very specific structure, that's called a schema. So when you want to give it a schema, there is a specific approach you have to use. And what the professor, what Answer did in this, he went into ChatGPT itself, because he's not, what he did initially is what we normally do, right? We all go to the documentation, and then we look at the specification and then try to figure it out, and it takes ages, right? It takes hours to do that. Instead, he wanted a schema for this. So he just went to ChatGPT and said, I want a schema for this JSON. And then he put this in there. And so this is an example of, although this is a JSON object, but this is an example of how it generates code. You can generate code by just explaining your problem, and it generates the code that you want. And we will go through the various aspects of this code, which is over here as well. So first of all, in a JSON schema, you have to first tell this type. This schema has been set up by the organization that deals with creating JSON schemas for OpenAPI. Okay, so it should have a type, and so the type says it's an object, and there are some properties for this object. So as you can see, it's just like a dictionary, right? So the first property that we want is the state. Okay, so this is the first property that we want in our JSON schema, and then we have to explain what this state looks like. So again, state is also an object, so that's what we put here, and then we put some description about this object. This is not what do you call for it? It's so that the API, when it looks at this schema, it knows what this object is supposed to contain. So that's what the description contains. Then within state, we also want these particular fields, right? Name and code. Again, you give it the property name, you tell it's a string, and then you explain, okay, this is the official state name. Inside state, there is another property called code. It's a kind of string, because remember, this is not an object now, right? Initially, state is an object. You can see that it's a dictionary object, right? But name is not an object. Name is just a string. Can you all see that? You will have to give me some audible feedback, right? So that I know you guys are following along.
Yes, we can see.
Okay. But it's clear, right? Does anyone have any question? Because if I go forward and you don't understand this, then it will be difficult to understand what's happening.
Could you please scroll down?
Okay.
The schema should contain type and it should contain properties.
Correct.
These are the first two things we are doing. So as per our requirement, initially it is schema is object type, which is having properties, various properties like state, country, and zip.
Correct.
And state is again, we have to give type and properties. For each and every thing, we have to give properties, type and so here state is again an object, which is having different properties like name and code. Again, name we have to give what is the type.
Yes.
And the description. Type and description will be the final thing for each
And
and everything.
Yeah, and you have to follow the nesting as well. So that's what's happening here. The nesting is being followed. So at the top level, you have an object, this is an object. So if you look down through this, that is the whole object, okay? And then inside that object was some properties, like you said, state, country, zip. So if you look at the next level of nesting, you can see state, same level of nesting, country, same level of nesting, zip. So you got that next level. Then inside that is the next level of nesting. So state itself is an object. You can see because of the two brackets, the curly braces on either side. So that's the whole object. So inside that object is also some properties, name, code. So you can see over here, this is inside the next level. So you can see name, code, and that's what you have to do. Type, description, and properties. These are the things that are required. And you have to follow the nesting level. Then at the very end, there is one more property for the main schema. Here they have put that these are required, because sometimes you can have some things that are not required, right? But you can say in this particular object, these are absolutely essential to be there. So that's why this extra field is saying that this is required. Yeah.
So like this
Everything is having a required property also.
Yeah, in this particular instance, he has put required for everything, because you can have a state, but then you can say, okay, I want only name but not the code, right? But you will fulfill the requirement that state is required.
So this description part, it is just for the reference purpose. Now, otherwise, there's no use for the description.
I'm not entirely sure. I think it's because my suspicion is that it might be used by the Open API to understand what goes inside those various things. Because what happens here is when we do the function call, we pass it the function extract address. Then how does it know what it's supposed to do with them, right? So the only way it would know that is, so imagine if I had just written some property name that said something like, just some random word like X1 or something. How does it know what this is, right? So these are just labels. Okay, remember, these are just labels. These are properties, right? So these are just labels. It doesn't explain anything of what's inside them.
Yes, sir. The properties are important, and what are its uses I understood, sir, but that description part, details about the state or
Yes.
description, official state name, these are all just for the reference purpose, so that we can know that it is just referring to the state name of entire state.
Okay, I mean,
Dictionary.
we can experiment, right? So what we can do is we can remove these descriptions completely and then submit the JSON into the function and see what comes out of it. Yeah.
No,
If
but
it's
we have
still,
to see the schema also, no? Like schema may have a condition that description is a required one. Okay, you
yeah,
want to
but
say empty string.
correct. Yeah. So, I mean, that's something we could try. If you guys have your notebooks open, why don't you give it a try and let's see what happens? Do you guys have your notebooks open? Hello?
Yes, sir.
Yeah, because when you try it only we will learn, right? So why don't you go ahead and give it a shot and let's all see the result. My suspicion is, my inclination is that this is useful to the OpenAI LLM to know what actually to do with these things. That's why we are giving it a schema like this. Because if it was optional, then there's no need to put it in, right? I mean, we can see ourselves, right? This is state. This is the name of the state. This is
Yes,
the
sir.
code. Why do we need these references? We don't, right? We are human beings. We can read it. So my inclination is to believe that when you submit this schema to Open AI, it reads through this whole thing and recognizes what should go in there. Because then when you give it the actual data, then it knows what to put where. That's what I think this is for. But we can try. You might be right. Okay, I'm also new to this, so I have not tried it. But I can get this set up if you want. But you also guys can try and experiment with it. I think this is my key. Let's see. I'll have to make some changes here. So I'll run the schema. Actually, let me remove these. Actually, first let me make a copy of this. Copy. Oh, right. Yeah, I have to that in your copy and drive. So we'll run this and see. Meanwhile, you guys also give it a try.
Yes, sir.
Okay. So there's the key. And then we're going to remove these things and see what happens.
So, sir, entire description part should be removed. No, we are just
No. The
keeping it
schema is
empty.
no. The schema is required. This schema is a required schema. This is a requirement in order to parse this JSON correctly by the Open API. But we can pass it empty string, right?
Yes, sir.
Okay. So we have removed all that. In fact, let's do something even harder. Let's put something confusing here. Let's say country name here and see what happens. Because then we will know for sure if it really matters or not, right?
Yes, sir.
Code. Let's say code. It should be a 10-letter code. Okay. Right. So the schema is done. Let's put the. It's a good question. Okay, it's not a bad question. There's no bad questions about this. This is all experiment, and we are all trying things. So let's. Yeah. this in here. Okay. So we are sending the schema, get the address. If unsure, leave blank. Fine. So let's see what happens. Okay, there's an error. What's the error? Address is not defined. Oh yeah, I have to load these addresses as well. If I go to the bottom, let's see what happens. Oh, something else went wrong. The key is not working either. Oh, API key not defined. I didn't run the first cell up here. Okay, that's running. Now let's see what happens. Okay, something's still wrong. Requests not defined. Okay. Right. Something's happening. Oh, something else went wrong. Let's see. JSON is not defined. From, I think it's from requests, import, request maybe, I think it was. I don't remember. Was it request? Yeah, no, it was requests. No. I don't remember what the library exactly was.
So you just
Requests, that's all.
Just requests, is it? I tried that, but it said then JSON was not defined. So
yeah,
that's why I was...
you need to import another library.
Import JSON, that's...
Yeah.
But this is from the request library, right? Okay, what we'll do is, let me try this. From requests, import JSON, and what was the other one? Response, right? Let's see if that works. It's R, I think. And JSON. Okay, let's ask ChatGPT. It's a good time to ask ChatGPT. I don't remember what it was. So
Can't we just
So
import
JSON is a separate library.
oh, it's a separate library. Normally requests has a JSON thing. So
But we are using JSON that loads here.
these ones. Okay, yeah. Right. Okay, ran it successfully. Let's see what it did. So that's interesting. It didn't give out the output we were expecting, right?
Yes, sir.
So do you think the description is optional?
No, sir.
So that's why I said that this schema is there's a very good reason for this schema. LLM won't know what to do with these words. For them, it's just words in a schema, right? These things are just keys for the LLM, because this is a JSON structure, right?
Yes, sir.
So it doesn't know what to do with these keys. So we have to explicitly tell what to do with these keys, right? So let me, I don't know if I can undo those things. Yeah, I can. Yeah. Okay, let's now try it with the descriptions and see what happens. If we still get, so you can see here it's like all messed up, right? So let's see what happens. Oh, it's still the same. Okay, interesting. What's gone wrong
So this
now?
is what happens, sir. You think for the if you go in the direction, but that direction comes out to be a dead end.
Yeah. Okay, let's see what.
The zero address, it is having state.
That's a good question. We'll try a different address. Let's try number 2. Let's try number 2 and see. I mean, you guys should be trying this as well, right? So just give it a try. I'm going to try it on another one. Let's see. Number 2. Let's see. So
State is New York.
Yeah, so it got New York as the state, the code for New York. It got the code for New York. Okay, so this looks fine, right?
Now you can remove the description.
Yeah. Now we can remove this and see what happens.
At least for one, only that you can state only you can remove. No, then okay. This otherwise
So
you can remove later on.
state has a code and state has a name. We'll say code for state or something. See what happens. Maybe it ignores it. Who knows?
It still came.
It
still came. Yeah, maybe the description doesn't matter. Maybe it doesn't matter. It still came, right? Let's try another. Yeah, it still comes. So maybe it just ignores the fact that descriptions are not necessary.
Maybe it is for the readability with all those things are there, no? Like our comments.
Possible.
Yeah, it's for it's user reference.
Yeah, because it seemed to have ignored the fact that I said code for state, right? It just gave the state name itself. Or we can try. But yeah, I think it ignores the description probably. Yeah, I think it ignores the description. Okay, so we learned something. It ignores descriptions. But shall we try removing the
Whole description.
the property?
Yeah,
Not
so
property.
maybe,
Sorry, the key.
yeah, am I audible? Hello? Am I audible?
Yeah, go ahead.
Yeah, so I was saying that if maybe the name is confusing, like you said, maybe instead of state we give X1 or something like that. Maybe
you change the label, you mean?
Yeah, you change the label and maybe then it focuses on the description or something.
Okay, let's say street or something. And we have given it a weird description, right? We call it country name.
So for code also description there is no string.
Yeah, we removed that just to confuse it. So let's try that.
Carlton, this is the answer given by ChatGPT.
Go on.
I have put it in the chat box. The description property of JSON schema provides a human readable explanation.
Yeah.
Or details about the purpose and usage of the schema element it is associated with. It helps developers and users understand the context, meaning, and intended use of the data defined by that schema element.
Okay.
This can be especially useful for the documentation, tooltips, and enhancing clarity when working with complex JSON structure. That is the purpose.
Yes. So thanks for that. That's a good example of using ChatGPT to find the answer to something we don't know. So yeah, good job, Naren. And who was the person who asked the question? Because that was a good question. Okay, now this is interesting. So we changed the label, and it gave us completely garbage stuff, right? Hello?
Oh, can you scroll up? I did not, that what 2 minutes I left that place.
Okay. So someone suggested, who was it who suggested? Who was the person who suggested to change the label?
Yeah, it was me.
Sorry, what's your name? Sarthak.
Sarthak. Yeah.
Okay, yeah.
I suggested.
Okay, yeah. So that was a good suggestion. Change the label and see what happens. So we know that description didn't make any difference. But if we change the label itself,
Where is the
so
label actually?
So it was state over here,
Oh,
right?
street. Okay.
So I changed it to street, but it still had name and code here. Okay. And then when we ran it this time, now what we got was a street name here, and we got the code as Hollywood. So that was interesting. So labels make a difference in the schema.
So your X1 will not work.
Sorry?
X1.
The first address you mean you're talking about?
No. We were
You mean the label?
Like you change the state to X1.
If the label is changed from
X1.
state to X1,
It was some time back.
Yeah. You can make X1, X2. See what happens. Yeah, it's now not sure, because in the prompt, if you looked at the prompt, it says here extract details, and then over here, oops, in the messages part where we say role and system, it says get address as JSON via the extract address. By the way, we have to talk about this. Okay, this is an important topic. I'll talk about it now that we have done our experiment. It says if unsure, leave fields blank. So it's unsure what to do now in some of these things. So it has left them blank. Okay, so what have we learned about the JSON schema? The labels are important, but the descriptions are just for human readability purposes and to help us with tool tips and things of that sort. So thanks guys for correcting me about the description, because I was under the impression that it was required so that the LLM interprets it correctly, and I was wrong. And you guys did a great job, asked great questions, and this is the way we learn, right? So we learn by asking questions and challenging assumptions. So that's great, that's wonderful. Okay, now the next thing we'll do is this is actually, the next bit is a very important topic. I'm going to do it with a small demonstration. So let's clear all this up from here. Okay. Now I'm going to use the prompt first to demonstrate what this is. Okay. So okay. This is a function called reverse. I want this function to reverse a string that I give you. Okay. So you can see my screen, right?
Yes.
Okay, that's not what I wanted. I don't want to use any code. I want you to run a function. Okay, so you can see this, right? Sure, I can help you with that. Please provide the string you want to reverse, and I'll demonstrate how the function works by reversing it for you. So I'll say reverse, and let's put something in here. Let's put Suresh. We'll put Suresh and see what comes out. Now notice it's actually thinking now. Okay, that's great. Now this is okay. This is not bad. Now I'm going to do something else. I will give you another function called, let's call it trim. I want you to trim the first and last letters of this function. Of this the first and last letters
of the string.
of the string. Okay, you don't want to use any code. Stop. Oh, okay. Don't want to use any code. I want you to run the function. Okay. I'll have to. Okay, is it working? No. Okay. Let me reload this chat GPT. Okay. I don't. Okay. I'll start with the different prompt.
Carlton, you can go to your original request. There only you can edit it.
Correct.
And run it.
I don't want to use.
No, this is for the reverse. I'm asking for the.
Yeah. No, I understood. But I want to demonstrate something. That's why I'm doing it.
Okay.
This is a function called reverse. I want you to. Function. The second function is called trim. To trim the first and last letters of the string I give you. Okay, let's try this. No, I think I have to reload this actually. Okay. I've reached the limit for ChatGPT 4.0. Okay. Right. Okay. Let me use the other ChatGPT then. I don't know if it will let me. Okay. So this is 3.5. Okay. It will work in 3.5 also. So I want to create two functions called so please bear with me, okay, while I type this. Using code. String. Okay. Okay. I want to do. I give you. What I should have done is save the prompt I used earlier. Then it will. Then it will have been okay. Okay. So 3.5 doesn't have that capability. Okay. What I was going to demonstrate was I initially created a function called reverse. Okay. And as you expect, it will reverse a string. For some reason, I've run out of tokens today. Probably I've used a lot of tokens already. And once it reverses the string, when I give it a function like this, okay, and it was very impressive when it was able to do it. I say trim, reverse, and then give it a string here. So like say pineapple or something like that. And what the response it gave was exactly what you would expect a Python function to do, which is it trimmed off the first letter and the last letter, and it reversed it. So it was able to understand how to run the code without you typing a single piece of code. And the reason it's able to do that is something called, I think the term is called function, what is it?
Functional programming. It
No, no.
always comes from left to right, no?
Yeah, no. But in LLM, there is a specific word for it. It's called,
Okay.
actually, it might be in the notebook itself. It's called function calling. That's what it's called. So basically, ChatGPT has the capability. So these prompts that you give it, you can actually encapsulate that prompt. Remember, like yesterday, I was saying these prompts that you give it are basically some transformations, right? That's what's happening in the background. Do you remember when I was talking about that yesterday? So these prompts are some sort of transformation that's occurring, and you can encapsulate this, what you would call as a prompt, and getting some inputs. That's kind of like a function, right? Which is, in a function you give some parameters like you do here, and then you do some processing on it, and you get a result out of it. Right? So that's the kind of function, right? That's how functions work. But LLMs themselves have something similar, and it's called function calling. And what function calling is you define a function, and that's what's happening over here. So if you look at this body that we have here, this is slightly different from the previous types of code we were using. It still has the URL, it still has the headers, but this bit is quite a bit different. So of course it has the model, it has the response format, but there is something new here. Okay, this is quite important for you to understand now. It's unfortunate that I could not demonstrate it on the chat GPT itself, but it was really phenomenal. So in fact, it's a very powerful tool. So there are two new properties, tools and tool choice. Okay. In tools, what you're doing is you're telling ChatGPT, I'm going to give you some few functions. They call it a tool. Okay. But effectively they are functions. And in this situation, we have only defined one specific function. Okay. So there is, in this toolbox, you can think of this as a toolbox. Okay. Where it says tools, between this two brackets, which is a list, it's a list of tools. So you can think of this as your toolbox, and you tell it what's in this toolbox. So I have a function in this toolbox. Okay, what is the function? Okay, the function has a name, and the name of this function is called extract address, which was exactly what I was trying to do here in a very wordy manner. Okay, I'm trying to say this is the function, reverse. Okay, so that's exactly what I'm doing. I'm saying this is the name of the function, extract address. What do I want this function to do? I want it to, and this is where you tell it what you want it to do. You want it to extract the address details. Now this description, this I know for a fact is not what you call for it, not optional, okay? Because this is actually part of your function prompt is what this is, okay? And then you give it the parameters and the schema that we had earlier. So this is the input that is coming into it, and this is the what it's supposed to do. So
Carlton, I think it may be different also, because extract address function is already defined somewhere. No, we have defined it somewhere.
Yeah.
Extract address.
So if I show you, here, tool choice, okay. Look what it says here. Get address as JSON via what?
Extract address.
It's calling this function.
Yeah.
Do you see that?
Extract underscore address, are we defining, or it is already?
Yeah. No. Yeah. We are defining this function.
Yeah.
That's why I wanted to demonstrate this here, but unfortunately I could not demonstrate it here. But we have tried this earlier, and so imagine I call this extract address like this. Okay. Imagine I called it like this. Okay. This function, what does it do? How will ChatGPT know? It doesn't know, right? So that's what we do here. We define this is like a function definition. What does this function do? Extract address details. And then it has the parameters that we give it, which is exactly what you do in a Python call, right? You have some function body and you have some parameters that go into it. And that's what this function does. Now you may think, well, this is not necessary. I can just do this here, right, in messages. And that's true. But what if you have something complex that you want to achieve, right, which uses nesting of two functions, like how we did over here? I was going to reverse and trim at the same time. And what it would have done, it would have understood, okay, first call this function trim. Once it does the trimming part, then call the next function to work on the output of trim, right? That's exactly what would have happened. So in that case,
that demonstration is so necessary. I can share my screen.
Yeah.
I have 4.0.
Yeah.
I mean,
you can, what you can do is you can try on there. In fact, I'd encourage all of you to try to create two functions and not use, tell it you don't want any code. You want the LLM itself or ChatGPT itself to run the function. Because we have tried it ourselves. I just wish I had copied the prompts we used, because then it would have been just copied, so you could see exactly how we achieved it. But of course, in language, it is difficult to express how to define a function, right? Whereas this is a very clean way of defining the function. And it's like I said, this toolbox can have many functions. So this is one function, extract address. So we could have had a function here that says trim, okay? And then we could have created another function also called reverse, and then we give it the details, and then we can tell what tool choice. That's the next part of this construction of this JSON body that we did. The tool choice, and we say, okay, these are the tools that we want to use. So, and then we put it here. So this is a function definition, and this says the tools we are going to use in the prompts that we are using over here. And then you see over here, when we give the prompt, we don't have to again describe the whole function again over here. Now you may ask, okay, what's other than the fact that this is convenient, what other value does this have? Can anyone tell me what value does this have to do it like this? To just use this function name over here instead of defining the whole function name. Can anyone tell me? Think about it. Think about it. There's a very important reason. So one is, of course, the convenience. You have defined a function and you can call it again and again. What is the other major advantage of this? At least brainstorm. Tell me what you think. Because this is an important topic, function calling. And it will be very important for you going forward when you use LLMs in your own clever programs that you're going to create.
Does it have something to do with defining function in public domain or private domain?
Say that again. Sorry. Could you repeat that again?
Does it have anything to do with defining a function in private domain or public domain?
Not that I'm aware of. No. In fact, I'm not sure I understand what you mean by that. Could you explain it for us?
Like if we are defining the function extract address somewhere outside this function, we have defined it in a public domain, right? And if we are using it like inside this function, that the domain of this function is only like this function.
I don't know. I don't know the answer to that. Not sure. But that was an interesting thing to investigate. So we can explore that further maybe at some point. Okay, so that's one suggestion. Any other suggestions? Okay, let me ask you this. when you type words, then we talked about this yesterday. When you type words to the prompts and you give it inputs, they cost tokens, right? Hello?
Yeah.
You guys know what tokens are, right?
We discussed in, I think, previous one.
Yes, yeah. So all these sentences, they're made up of tokens. And I think Amit demonstrated to you yesterday.
OpenAI website, I think.
Yeah, that's right. That's right. There's a link, in fact, on here somewhere. Tokenizer, this one. So when you put some prompts into ChatGPT or any LLM, it creates some tokens. So let's say, for example, I use this itself, and I say, okay, show me the tokens. Oops. Okay, and you can see here, there are all these tokens. This costs 48 tokens. Okay, and each token that you use when you're creating prompts and also the inputs you're giving, they cost some money to run. So what is the advantage of using function calls now that you understand that concept?
No, we are not sending the entire question.
Correct.
We are. It is not
Correct.
requesting for the post request is not there for each and everything. No, like
Exactly. You hit the nail on the head. If you had now, remember yesterday you were sending some movie reviews and you were hitting the API, right? And when you were hitting the API, every time you hit the API, you had to send a whole big explanation to it, correct? And it was going, each time you hit the function, it was sending the prompt. Now imagine you send only a small function which has been defined once, and then you call the function again and again. OpenAI, as far as I remember from the lecture, our Chanan said, when you use this, the tokenizer doesn't cost you anything for calling the function, or it costs you only a very little to store the function once. It doesn't have to think again and again about this function. It doesn't have to process your language again and again. This prompt, it doesn't need to do that. And so that's what the big advantage of using function calling is. So did someone send a message? I heard some noise.
Someone left, I think.
Okay. So that's the one big advantage of a function calling. When you define functions which do some complex processing, then you can nest them. You can use several functions together so that you can achieve some greater goal for the AI. And then the most significant thing is the cost. It reduces your cost significantly when you use a function, because once it's defined, OpenAI has already spent the processing power to parse what your function means, and it doesn't need to think again about what it should do with that prompt that you give. So that's the value in function calling. That's why this is a fairly important topic. And of course, this is a lot of new things that you're learning, and it will take some time to get used to it. But the structure, just remember the structure. It's the same like any other API call you make. But the main thing is you're doing is this time you're having a tool, something called tools, and think of it as a toolbox. The toolbox stores some function definitions, and this is the format of it, and it's available in your portal, so you can look at it again yourself and play around with it. And then you can tell in this particular section what tool choices you want, and then you send your prompt as normal, and you can call the function using this name that you're given to the function, whatever name you're given to the function. And that's what function calling is. If you haven't watched the lecture video, I would highly suggest watching it again. And hopefully for next time, you guys can either mm, practice doing some little function callings and see how it works out for you. Okay, and we'll prepare a pre-recorded, maybe a pre-recorded, or we'll do a live demonstration of it using the language itself over here. Because in fact, yesterday when Amit and I were preparing, we tried it out, like just using OpenAI's normal speech, the parser over here, and it worked fantastic. No matter how many times you called the function, it would do exactly what you want, and you could nest the function, you could do crazy things with it, and it was really cool to see that it was able to do that without writing a single piece of code. That was just incredible. But that's what this is. This aspect is called. It's called function calling in LLM. Any questions so far? I know it's a very dense topic, and these formats and everything is new. So, if you've got any questions, you can ask me at this point. No questions, guys. I get nervous when no one makes a sound. Okay, because I think no one's understood anything, and everyone's just keeping quiet, or you've fallen asleep or something.
Yeah, there are two things if there are no questions. One is we all understood everything or we did not understand anything.
Yes. So that's why something, if you say, it would be good. Like, yes, we've understood. Or,
As you told, no, we'll have to try out for ourselves. This is only
yes.
the first thing. Okay.
Yeah. But you understood the structure and everything, right?
Yeah.
What we
Yeah,
have talked
we
about.
are
Okay.
at least 70-80%, and we have to see again to understand fully, maybe.
Yes, just try and practice it, and you will have a look at it. You've got some free tokens courtesy of IITM, so make use of them. Try a few experiments, and see what you get out of it.
Carlton, by the way, I mean, just as academic interest for the exam, we may not be getting any question on this in the ROE, no? Chances, probability chances.
In ROE, I mean, I don't think you will get a question on this. Okay, that's not generally what will happen in ROE. Can you use LLMs to help you in ROE? Maybe.
Can you is okay. Will I mean, should I use?
It depends how proficient you are, right? Because okay, I'll give you a real life example. Okay, I don't have it currently now because I've run out of tokens, but I tried this recently. So you guys were doing project, right? We have submitted, rather we have deployed project for all you guys, right? So if I show you this, okay, I'll tell you what happened. So actually, I have a link for this here somewhere. Election Commission, yeah, this one. Okay, so this is a real life example, okay, and it just blew our minds away. So if I look at some, okay, I know that now they have cleaned up a lot of it, but let's look at this file, say from 1951 or something. Okay. But a lot of these now have been kind of converted into something better. Okay, so this file is quite huge. I think there is like hundreds of pages of information. Okay, and this is the kind of work that had to go into preparing your data set. So you guys got it easy. Okay, we had to slog our behinds for getting you something reasonable for your project. Okay, so we get all these results from the state for that year, and you can see it's very much okay. It's sort of semi-structured. Okay, but you can't. It's very difficult to extract this. It's very difficult. Even if you use Tabula or whatever it is very difficult to extract this information. In fact, if you go to the summaries, yeah, these are summaries, right? So yeah, very difficult to extract this information. You have to get party, candidate, votes, and all that, and everything, and it has to be in that table format that you can see on the website. Okay, it's got to be in this nice format. Okay, so you can imagine how tedious this work would have been, right? And eventually, to scrape just a few of these PDFs, Now, what you saw here, right, this PDF, this is actually a cleaned up PDF. The original PDFs were not even this good. Okay, this is the Election Commission has redone these, so that's why it's a little more, newer font and everything. But the previous ones, they were just scans of actual pages. Okay, so imagine trying to extract data from that. So what we did was we ran a little experiment. We uploaded the PDF in. We uploaded one of the election PDFs into ChatGPT, and we said, okay, ChatGPT, we want you to produce a CSV file with state name, year, state name, constituency name, candidate name, and votes. So we told it this instruction, and we gave it this very unstructured file. Okay, and you won't believe it. After about 2 minutes, it gave us a perfect CSV file. And then we could even ask questions. We could say, okay, which female candidate, how many votes did the female candidate win in this particular constituency? And it was able to answer it by looking at this unstructured PDF. And it was mind blowing, because even 2 years ago, doing something like that would have taken you days of work. And now it's able to do it in 2 minutes. It's able to pass something as a natural document, and it's able to give you a structured output. Remember, today we were talking about how to get structured output out of unstructured data, right? This is an important topic. And this was a silly example. That was an amazing example. Now, the reason we didn't give you PDFs is because that takes massive amount of tokens. Okay, when you submit a PDF has not only all the language in it, but it has all these unusual document tags and things of that sort that are specific to the PDF. And that's what we found in the ChatGPT, that we were able to extract very perfect structured information out of a PDF. But it was very limited for us because it just used up all our tokens in one shot. But that's the future, that this is going to become big in many parts, aspects of life. So that's why this topic was important, and that's a real life example of how this can be leveraged. And this is one of the ways you can use it. You don't have to use the prompt in the front. You can create an application. Maybe if you're working for the government or something, they will ask you, okay, make an application. We have an unlimited budget, so write a prompts and create some nice structured data for us to put on the site and to process it, right? So you could theoretically do it now with what you've learned so far, right? So that's what I wanted to share with you. I hope that was not a boring, long, lengthy discussion about it. Because we were just blown away by the capability.
Yeah, with function calling, if you want to upload the PDF, do you have to extract the data from the PDF first and then you have to use it, or can you directly upload the PDF?
I'm not entirely sure. I suspect what would happen is the content, we'll have to look up the API documentation to see how you can upload a file. Because normally here, when you go to ChatGPT, they have an attachment. See, can you see this button over here? Yeah. So right now it's not letting me because I've run out of the limit. Okay. But normally what you can do is you can send a file. So that's what we did. We send the PDF, but that consumes tokens. Okay. Don't forget that. So even the file you send will consume tokens. So I'm very sure. I'm like almost 99% sure. Just like how you can send this JSON body.
Carlton, I would like to add something.
Yeah.
See, basically, what we are using this Chat GPT, and what are you talking about? The tokens are two different things. Tokens where paid is that OpenAI, the Chat GPT is having. No, if you want to extract using that, that only requires tokens.
Correct.
And what we are using, this 3.5 turbo or 4.0, these are different. This 4.0 is a subscribed version of ChatGPT.
So this is also a subscribed version, the 3.5 turbo that we're using.
Okay,
That's
whatever.
why.
No, whether 3.5 or I mean, if you go to your ChatGPT screen, no, can you go to that screen?
Yeah.
See, it says no ChatGPT one down arrow mark in the left side top corner.
This one. No, that's
top left side. Yeah. No, ChatGPT is there, no?
Okay. Yeah.
This is ChatGPT plus ChatGPT, and you are having two things, isn't it? And upgrade plan is there. You can select any one of them. If you upgrade, then only you will get that 4.0 or whatever it is.
Of course, yeah.
So in 4.0, we can use, I mean, with you can use unlimited whatever you wanted. You can use if you are having a subscription for 4.0.
It's not unlimited, but it is
user policy. There is some policy, no, like standard user policy or something.
Yeah. So there is a limit, but it is more generous for those who pay.
No, that's what that limit is basically unlimited, but only one condition is saying is that there is some words for it, no, like user something is there. It is basically for our level, it is unlimited only.
It's commercial usage.
It should not be commercial use. It should be for personal use. And here, when you're saying the context of my tokens are over, this you are not able to upload certain things. You know that jump clip you are not able to use. That is because the ChatGPT has given like Geo they gave free. Like that ChatGPT is giving this 4.0 free for certain hours in a day or certain tokens for a day.
Correct.
So that is why tomorrow you will be able to use it. Actually, you're not run out of tokens entirely. It is for every 24 years.
No, I understood that. That I know. It's sorry, I misspoke. I understand that it renews every day a certain number. That is true.
That is for certain days. They are giving free.
Yeah.
But once you are subscribed to 4.0, no, then it is almost unlimited. And this for one point. Second point, whatever you're talking about tokens, no, that is only for API. If you want to use it in your program, for each and every, for example, what are the JSON, what are you doing, or movies you're doing, no, like you can do for single item in this window, but you want to do it in for a list of movies 10, 20, 15, and you want to use that, then you have that API thing coming into picture. I hope I'm able to tell you something.
Yeah, but that's exactly the problem, right? When we want to do something, we don't want to do just one thing, right? We want to do it programmatically for a large number of things.
Correct. No. What I'm trying to tell is this, whatever screen you're showing right now, this is different, and what we are going to do with .api is entirely different. /API rather. So I think we are mixing both things.
Okay. Okay, maybe I don't know. I'm not sure. It's all new to me as well. So
that's why I just thought I will give some insights for what I have seen.
Okay.
Because I am subscribed with 4.0.
Okay.
That's about $20 per month.
Yeah, that's nice.
When I wanted to use the tokens, no, like our 50 cents tokens they have given us.
Correct.
So I searched whether I can use the tokens with this subscription. It says no, it is different. You have to subscribe that separately. It will be billed to you separately. Then I did not use it. Okay. I'm trying to use that $0.5 dollars only, cent for 0.5 cents.
Yeah, I mean that's very sufficient for the work that doing the graded assignment. So that's
I'm sorry, I just barged in when I just I have to share this.
Yeah, no, that's fine. But ultimately, the issue is the same, right? Which is we can't do large programmatic things in this window, right? You understand what? Yeah, means what I'm saying is, let's say, for example, you want to do some large amount of processing. Like say, I've got 4 lakh lines of election data to process, right? I can't use this window to do that, can I?
I don't know. I'll have to check up, and since you gave me a nice idea, no, like whatever project 1 is there. I mean, small data I'm doing actually. I can download that in a file, CSV file or Excel file, anything. I go to here and attach that file and ask questions. It will give me the answers.
It's
Sure,
giving.
sure.
I just tried it. It's working.
So it is giving the answers for MLP and all. It is or whatever TDS also. Anywhere you can use that.
Yeah. And like I said, we encourage you to use whatever you can to.
Only in TDS you are encouraging. All other courses they are not like BDM and all. If you use ChatGPT, you are straight away rejected.
Oh, right.
BDM
Okay.
project. Sorry, just out of
Anyway,
the way.
I mean, Anand sir has told us openly. I mean, he sent a mail today specifically stating to us that we should encourage students to use ChatGPT, and he specifically told me not to answer questions without using ChatGPT. Like, for every step he wanted me to use ChatGPT. So, but as you can see, I ran out of tokens very quickly. So.
Okay, no problem. Please continue. I
Yeah,
interrupted
no
you.
worries. Yeah, no worries. So, okay. The next thing is we were going to talk about. So we know what LLM extraction is about, right? So we examined it, and so that's fine. Next is called LLM topic modeling. Okay, so is it LLM topic? Yeah, I think so. Okay, so embeddings. So I'll open this notebook because it's easier to talk through it. Okay, so as you know, ChatGPT uses the idea of tokens when parsing any kind of prompts that are given to it. Okay, and these tokens that ChatGPT uses, they all have some sort of scale, some weighting scale. Okay, so for example, if you look at these words over here, it might give a weight of, say, some number it will assign to this: apple, orange, banana, Jamaica, all these things. It will attach some numbers to this, and these numbers that it attaches to these words, and it won't be just one number, by the way. Okay, there will be, each word will represent an entire association or an entire uh, array of relationships. Okay, so if you think of, say for example, Naren. Okay, now Naren has many relationships, right? He's a son, he's a friend, he's maybe a brother, or he's a colleague. Many relationships he has, right? And he'll have it to different people. And each of these relationships that he has, there will be some weight to it. So the closer relationship will have more weight to it, maybe. And some of the acquaintances, people that maybe he's seen on Facebook and they're just Facebook friend type thing, they will have very less weight to them. But all these weights of these relationships, they all connect to Naren. Okay. So in the same way, the word apple can be, has many relationships in language. Okay. Apple can be related to a tree. It can be related to a fruit. It can be related to the company Apple. It can be related to a pie, so apple pie. Or it can be used in a figure of speech, though the association is weak. So you can say someone is the apple of my eye. I don't know if you heard that phrase. What that means is, when you say, that person is the apple of my eye, that means that person is very close to you. So that's what it means in English, right? So, but that's also an association, a relationship, and is based on the context. So someone somewhere has worked out mathematically all these relationships that these words have. Okay, and a word can have thousands of relationships based on where it is placed, how it is used, all these sorts of things. And what they've done is given it some weights, and these weights, okay, these numbers, if they have close, so say for example, if apple and fruit are related to each other, they will have a very close matching number. So if apple was given 1, fruit may also have 1. So that means it has a very close relationship with the word fruit. And if apple is a relationship 1 and company has a relationship 1, then very closely attached. So this is just a layman's explanation of it, okay? How words are related to each other. So what does this have to do with embeddings, okay? So this concept where a word has many relationships is called, these are called embeddings. And why is this important? Because what you will see as we go down here, for example, here, let's see. Right. So in this cell, he has taken these words and he has found out the embedding scores of these words. Okay, so you can see that many numbers are there. And I think, if I'm not mistaken, each LLM model has their own embedding score. Okay, and not only, and it won't be just a few numbers. One word could have as many as, I think it's something like one, in OpenAI they have as many as 1,500 or 2,000 scores or numbers attached to them. Okay, they managed to condense it down to 2,000 numbers. So each word is effectively an entire array of 2,000 numbers. That's what's happening in the background. So when you type Apple in your prompt, it's looking at an array of 2,000 numbers. That's what it means to the LLM. Remember, I told you these were mathematical transformations. That's exactly what this is happening. So then when you put words together, they form associations that the LLM understands. And so if you look over here, he's showing what each of these embeddings look like. And you can see it's a big, you can see these 3 dots. That's because it's a huge array. And then you get to understand how these words are associated with each other. And this is useful for many reasons. Why? Because you can do a lot of clever things when you know what words are associated with each other. Now, you remember initially we talked about sentiment, and where you looked at how words give you a bad connotation, good connotation. This is all done using this concept of how close words are to each other, right? So it's the same sort of principle. So when you want to categorize, identify things, how do you mathematically do it? And you will learn this in one of the machine learning courses also, right? You will look at a big array, a big matrix, okay? And all of them will have vectors in them, okay? Each vector will have many, will be multi-dimensional vector, or many features will be there in each vector. And that is what this is. This is like a feature. This is like a, not feature, what you call for it, a data point. And in that data point, there are many features for this data point. So it's a big array with a huge number of features, and we stick them all in the matrix. And that's why when you hear about AI companies wanting to buy graphics cards, the reason they want to buy graphics cards for their data centers is graphic cards are very good at crunching matrices, and that's all that's happening in the background. Huge stacks of mega machines are filled with these GPUs that can crunch matrices very quickly, because that's what LLMs are doing. They're taking the words that you're using and they're crunching, converting it into a large 1,500 dimension matrix, and then they are doing these number transformations. And to us, it looks like magic on the front. That's what it's doing. And how it knows the meaning of things, it's because of these embeddings. The close association of words helps it to understand the context, and that's how it how they develop these models. So how do we find out things are similar? So the simple layman's way of doing it is, if you multiply one vector by another vector, you do the dot product, you will get what you call for it, a result from that, right? You will get a scalar, and that scalar then tells you how close those two vectors are, right? If you remember in MLF, you would have studied, or in MLT, how you find out how close vectors are, right? You find out by looking at the projection, and you have all these concepts, which I won't talk about here because some of you might not have taken it. But that's the same concept. You multiply each vector with each other, each of these number arrays you multiply with each other, and you get a score. And you can see Apple is exactly the same as Apple, right? So this diagonal on the matrix will be 1, because this will give you the perfect association, apple and apple, right? Whereas these ones, because of the way the matrix features are, you can see this is somewhat related. This is also maybe a little bit less than orange. Then Apple and Jamaica, there's not really much relation. Apple and Sri Lanka, again, very low relationship. But then you can see Facebook and Apple, when you multiply the two arrays, you're getting a fairly strong association, almost as strong as orange. In fact, more than banana.
More than banana, yeah.
Yeah, but that's because if you think about language, right? When we talk about, so let's say someone says, did you know Apple, Facebook, and Google are the three biggest companies? Now, if you tell that to an alien, right, he might think, what are you talking about, right? Because Apple is a fruit. Facebook is, I don't know what Facebook is. Is it a book with a face? You know, but we know from context, because we are familiar with the context, we know that these are companies, right? Apple, Facebook, and Google. So that's why these number scores show strong association with the word apple. But also it is a fruit. So it has strong association with the word orange. So it completely depends on context. But that's what embeddings are. And that's what is demonstrated here. And we can use, then they talk about how you can use them in clustering. And this is how you can then categorize these various words. But you, not just words, but you can categorize lots of other things, right? You can, sentiment analysis was a kind of categorization, if you think about it. We gave it a whole bunch of words and then say, okay, categorize this into positive, categorize this into negative, categorize this into neutral. But this is showing the mathematical basis of how that categorization is done. And this is a idea called K clustering. And I won't get too deep into this now, and it's not that important in terms of the final exam, except you have to know what it means. Okay, because they always ask you questions in the final exam. What is they will ask you some question on K means. Like usually they will ask you, for example, if, why you have to choose. How do you choose the clusters, for example, right? It will be some sort of objective question. Do you choose more clusters, less clusters, and that sort of thing they will ask you. So you will have to know a little bit about k-means clustering, but I won't go into deeply into that today. The reason being, one of the things that we were instructed to do is we want you to type into ChatGPT something like explain in simple words what k clustering means and see what comes out of it and if you understand what it's saying. So they are strongly encouraging students to ask these kinds of questions but it doesn't mean I won't explain it, but I won't explain it tonight, okay? Because we are almost 2 hours into this session. But some of you would have done MLT, MLF, you would probably know already what K clustering means. But it's basically associating groups of various data points into clusters. And you find the clusters that have the closest distance to those data points. That is effectively what it means. But if you want to understand it a little bit deeper, we will go into it in the next session. And you can also explore it yourself with ChatGPT or whatever other resources. So that's about embeddings. Is it clear what embeddings are and why they're important in terms of LLMs?
Yes.
Okay. Any questions anyone has?
So these embeddings are basically how internally these models work. I mean, they give us the answers.
Yes, they give us a window. That's why, see, when people say, okay, AI is going to is self-aware and all that, that's nonsense, right? It's basically matrices that are running in the background. That's all it is. It has no self-awareness. It's just doing mathematical multiplications and creating these number associations. And they have done a lot of research into it. Okay, how do you define these relationships? So they've done all that. But now you have not the layman's view of it, right? As data scientists, you have a mature view of what AI is. So, when your family and friends talk about how AI is going to, conquer the world, or some, killer robots are going to walk around and wipers off the face of the earth. That's not what LLMs are going to do anyway. There may be other AI that might do that, but definitely not LLMs. Okay, LLMs are just big matrix multiplying machines. That's what they are. Again, you can see the associations, so how it's being categorized: company, fruit. Before we were checking their relationship with each other, right? Here it's checking the relationship with topics: fruit, country, and company. And this is just a simple example. You can come up with some ingenious programs, right, that can leverage these concepts or these ideas. So that's what the value in understanding how this works internally. And yeah, I think we will. That's all we'll cover for today, because it's quite a dense topic for some of you. So I don't want to overload you with things. So anything else you guys want to talk about, project or anything, any questions? It doesn't have to be just about today's topics, but any doubts you have, you can ask now.
Yeah, in the beginning you said there are some models we can download in our PC and run it if we have a good machine, right?
Yes.
So the thing we are downloading is those embeddings, because I think for good machine you are expecting to calculate all those things.
Yeah. So yeah, I think so. I'm not 100% sure of the answer to that. I think what's happened, what they do is they give you the already trained model. So that's why they are much more. They can run on a local machine.
Already it's calculated, I think.
Yeah, a lot of the calculations have already been done, and not only that, they've compressed them down also. So they have. I think if you go to Hugging Face, I think it's called Hugging Face. Yeah. So if you go to Hugging Face, they have models for all sorts of things, right? And this is really worth exploring, because there are free models also. Okay, there are paid ones, but there are free ones, and this is useful. You can find models that are fine tuned for a certain task. So if you want models for object detection, image to text, or any of these sort of things, you can get them. They even have like I think there were like some cool language ones as well, where you can use something for in local languages and things of that sort. But like you can do like image to text models, so you can download these models and you can see their you can see the
2 megabyte.
yeah how big and everything there. If you go here, you will see. So some of them are gigabytes in size. Okay, so just be aware of that. I don't know what restrictions you have on your internet at home or anything. So some of you have a paid data plan and all, but this is important. You can see the model size. The bigger the model size, I mean, the more number of parameters that the model size is, the more heavy it will be on your computer. So something like Llama, I think, is like the newest versions of Llama are quite huge. So okay, this is a very compressed one, so 312. But I remember there was one that had like more than a billion parameters. So I don't know which one that was. But anyway, so you basically get the model and then you load it into something called LLM Studio. I think it's called. Yeah, LLM Studio. This software, it's available for all platforms. And the best part, okay, now you're wondering, why should I do all this? ChatGPT is there. You know what the best part about this is? You can use unlimited number of tokens. Why? Because it's running on your local machine. It might take, depending on the model, it might be a bit slow in responding. Okay, so like it might take you like it won't be like within 1 second or 2 seconds. Maybe it'll take 3-4 seconds or 5 seconds to respond to something. But there is no limitation at all. You can just use it as much as you want. So that's the benefit of downloading and running the LLM locally. But like I said, there are paid models also, and there are free models also. And there are some very good free models. And you can again use this to experiment. They will have their own APIs that you can connect to, and it's a booming new era of computing that's coming. So I would strongly advise you to experiment. Maybe one of these days when we are not under any time pressure with exams and all, maybe we can even conduct an optional session where we will try and play around with some of these. Okay, I've tried it myself. It's quite fun, and you can try it yourself. So LLM Studio, and then get a model, import it into LLM Studio. There is a lot of documentation on it. You can give it a try.
Which model is better to try?
I mean, there are, you can even ask ChatGPT, right? You can say, name me some popular models. And see, the thing is, the model will depend on what your use case is. Okay. If you use a general LLM model, then its use case will be, in one sense, I don't want to say it will be limited, but in some ways it won't be very good at a very specific kind of task. Let's say you choose an LLM that is very good at recognizing objects, okay, in a pictures. Because remember, these AI models are not just for language. You can use them for even like image generation. You've seen like DALI and all these sort of things, right? You guys have seen AI generated images and AI generated videos, right? Where you just type some text and it creates the image or it creates the video. And so you can download all those things from Hugging Face. So it depends on your use case and what specific task it is for. So some are very good at translation from, say, English to Tamil or something, or English to Hindi. Some are very good at doing, say, for example, coding. Okay, so Codium is a AI model that is trained on writing code. So, say for example, you have MAD1 or MAD2 project. You want an LLM to help you write the code. You can use an LLM model that is trained on coding to be able to help you with it, and they are quite good, and they can solve some. They can save you a lot of time and improve your productivity. So that's why I can't say like, okay, this model is good or that. It just depends on your use case. You'll have to search on Hugging Face and type in there, like, model for coding or model for general tasks or a model for accounting even, if you want to do some accounting work or something. Okay, if there's no questions, then we'll commence tonight's session.
And one another doubt, this embedding numbers,
conclude.
do they change frequently when we train, or how is their fixed?
Good question. I think in the background, they probably change only when the model itself changes. So like 4.0 will have a fixed model that it works on. That's why they release these new versions, right? Because they've improved the model somewhat. So I think for each, again, I'm not 100% sure of the answer, and I can't ask ChatGPT because I can't put anything else. Maybe we can. Let's see. What was the question again? Do the embedding scores change when you use? Is that the question you were asking?
Yes.
So it gave me two responses and asked me to choose one. Itself doesn't know the answer. It's like, choose an answer which you think is good. So I don't know. I'm not sure what the answer is. Not sure. I mean, on some level, I think when you remember we were talking about multi-shotting and single shotting earlier on, we were talking about that. I think when you do those sorts of training, then it perhaps temporarily alters it just for your use case. Maybe it would make sense to do that. That is how it would know that the context has changed with the scores you are given it, right? So not entirely sure. I'm not sure the answer to that, but I suspect it maybe has some adaptability built into it. Okay. I'll say good night to you guys. I hope the session was useful.
Yes. Thank you, Carlton. Good night.
Okay.
Good night, Carlton.
Bye.
Bye.
Thanks.
Good night.